Today we have an iPhone 11 that has a backlight issue. As you can see here, there's a dark spot on the screen. It's not a parts issue, it's actually a motherboard issue. So we need to do micro soldering to repair this so we can get it fully functional. And if you need this repair, reach out to me through my website, which I will link down below. So let's go ahead and get started with this tutorial. First thing I do in these type of cases is first do a visual inspection. We do that by removing the foam around the connectors, because we're also most likely going to have to apply some heat. So if you apply heat while these are on, these will melt around the connectors and then make things difficult to plug in after the repair is done. So let's just peel these off like so. And then just a visual inspection to see for any pry damage, any tool damage, any water damage. I don't see anything. This is where the screen plugs in. This is the display and backlight. This is the touch connector. So we really want to just focus on this one, but just to make sure, check the rest of the board for any liquid damage or any kind of abnormal thing. But the board looks all fine. This is just a sticker that I just kind of peeled off. All right, the next thing is to diode mode the connectors. If you have an issue with displaying something on the screen, obviously first test known good parts, then you want to test where that part plugs into. So let's check this display connector. And here on the screen we have ZXW. This is a board view software that has known good readings so we can compare to. And this is the iPhone 11 motherboard, and we're going to zoom in to the display connector. And if you zoom in close enough, you see these red numbers. These are the known good diode mode values. So we use diode mode on our multimeter to read each pin and see if we find any abnormal readings. And then if you look closely, you can see these are labeled as PP display BL12 Cat2. So obviously display, and BL is short for backlight. Same here, BL, 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 BL. So all these that say BL12, BL34, these are all backlight related. The rest are image related. So we could just focus basically on just these 4 pins here. These other ones are data lines, so it has to be somewhere here. So let's start off by measuring in diode mode our connector here, and I have the board in the same orientation as ZXW. Red probe goes on ground, black probe is the one you probe with. So first one we get 598, whereas ZXW says 595, which is close enough. We want to look for a big variance, or like this one. There you go. See, so the first one we get 598. The second one we're supposed to get 454, but we get OL. OL is the same thing as nothing plugged in. So this is an open line, and then if I touch these together, we get a short, or 000. So OL means disconnected. So as you can see here, OL. The next one we get 594. Sorry, I got 598, 599. So basically, here's our problem, this pin here. So we got to trace this down to see where the problem may lie, which is actually pretty easy. So if we go back, so follow this pin. So here we have PP display BL, backlight 12 anode con. And then it goes to these 2 caps, which an OL will not be a cap related issue. So we can ignore these caps. Usually if we get 000, which means short, then that's a cap, most likely a cap capacitor, C for cap. So let's go, where else does this connect to? Oh, look at that, there's something here. This is R for resistor. And what we're gonna do is we need to check this resistor, because this is a component that's inline. So if this resistor is blown, it can cause an OL, because the circuit stops here. So it goes from here to here to here, and that's it. There's nothing else on the board that would be red where the path can continue to. The path stops here, and then it has to go through this resistor to this other side. Now if you put your mouse over it, we don't even have a value for this resistor, but that doesn't matter. We have to check this resistor because this is the next point of the circuit. As you can see here, on this side it connects to a bunch of other stuff, including a diode, another diode, an IC, and possibly a coil. Let's see. Yeah, so this side of the diode connects to this coil. So basically this is a whole backlight circuit. So it could be this resistor here is blown and causing that disconnection. And if we look here, there's actually a shield here. We cannot get to that resistor because the shield is here. Although there is a little hole here, probably can't look inside anyway. So we'll have to remove this shield to get inside. So what I would recommend is this heater here, the Mechanic IX5 Max. Excuse my tool, is very dirty, full of flux, because I do a lot of work on these, and I guess dirty. So what I'm gonna do is, because this it's actually here now, because this this motherboard is actually a 2-layer sandwich. So here, before I do that, it's a top layer motherboard, a bottom layer motherboard, and then the middle is the interposer. So we need to separate these to be able to work on this. Otherwise, the sandwich is going to separate while we're trying to solder on top of it, and it's not a good plan. So what I'm going to do first is actually, I'm going to use some hot air. So let's do just something like that, 230. And I'm going to clear this underfill that's pressed up against the shield that we need to remove. And I have the heater on. The nice thing about this heater is it's just on and off. So we don't have to set any temperatures or anything. It'll just get just hot enough to split the sandwich without messing anything up. So so what I'm gonna do first, before I even try to remove the shield, is split the sandwich. So we only work on the top board, do all our repairs, and then we'll sandwich it back together at the end. This is the safest method, in my opinion, to dealing with these sandwich boards and working on the top board. But while it's warming up, let's prep this shield for removal to save some time. And I'm gonna add some flux around the shield. It does take a few minutes for this heater to heat up the sandwich. So let's save some time here. I'm going to add some solder to the edges of the shield as well. This helps remove the shield a lot easier once it's time to apply hot air. So using my knife tip, it lets me get real close to the surface. So this shield is actually sitting flat, completely sealed off from the, like the shield is fully flat. Compared to other shields, sometimes they have like little gaps and stuff. All right, so I covered best I could, not everything. I'm gonna turn on my fume extractor. Essentially, we want to remove this shield, do all the work, put the shield back on, and then put the sandwich back on, and it's gonna be a lot of steps. So I'll be right back. Let's give it a few minutes for it to warm up, and then we'll keep going. All right, so it's been about 2-3 minutes. One of the things I look for is to know whether this is ready. Is I push down, and from the sides, I won't really be able to show you guys this, but from the sides I could see the sandwich is pressing down on. You can maybe see some factory flux kind of ooze out the sides, and really it takes no more than 5 minutes for this to heat up. So what I like to do is press down all along the board, any flat surfaces that won't damage anything. And then let's just put this here just to be sure. So this holds down this part of the board, and then this one here holds this part. So this is on the bottom board, this is on the bottom board. So that way the top board can easily come off. And what I do is with my tool 3D tweezers, which I highly recommend, is since they're so thin, I could come in here, grab it, and lift it up and separate it. And take a look at that. Let me turn off the heater. So this is the top layer only, which has the CPU, PMIC, and some other stuff. And then this bottom board has the cellular, Wi-Fi, and some other functions as well. So let's put this off to the side, since we now got to work on this board. And while I wait for it to cool down, I'm gonna get my board holder ready. I'm gonna clean my board holder. That way, when it makes contact with the board that I'm working on, it won't get any extra dirt or debris or anything like that. And it kind of sucks doing this because you know, after fixing so many phones and stuff, you know, this flux builds up and not much you can do. And I hate when stuff is real sticky. One of the things you want to be careful is that the board grabs onto the sides of the actual PCB board and not onto the sides of like the CPU or something like that, because then you could damage the CPU. So let's make sure that these side walls are grabbing the actual board. All right, so let's angle it like this, and now get my blade. And essentially I'm gonna try to fit my blade somewhere in here so we could try to lift it up while I apply some hot air. So I'm gonna use 380 Celsius with 45% air on this add-in hot air station. And essentially just go in fast circles around the perimeter. This should be enough to melt that solder. I'm just holding down the shield. So I think I was able to lift up a little bit. There it goes. I can see it lifting up. As soon as I see it lift up a little bit, I grab my tweezers so that I can better control the shield. There you go. I was able to lift it up without damaging anything inside. So I'll put this off to the side. I'll come back to it. So one of the things I do after this is apply flux on any chunks of solder that might be sticking out and try to flatten it. So using the back of my knife tip, I might have to apply a little bit of hot air to help assist in flowing this solder, because it is ground, and ground does require more heat. Basically, I do want to, because you have excess solder here and you don't want it to bridge with the surrounding components that are really close by, especially when you go to put on the shield. So we're just kind of trying to spread out the solder evenly. It's kind of a hard spot to reach. Maybe I'll do this. Well, there's nothing in that area. Those coils should be safe. I'm just too lazy to move my board. Alright, so now we got the shield removed, ready to inspect. So if you remember, the component we're looking for is this one. Right, so the idea is, if this pin is connected to these caps and connected to this pin, these are all one connection. So if this pin is 454, it's supposed to be 454, and this is supposed to be 454, and this is supposed to be 454. But also, if the line is supposed to carry over this resistor, and the resistor is really low resistance, in that basically just how resistors work is, if it's a low resistance resistor, that means the diode mode reading from here to here should not change, or it'll change just a little bit, depending on the value of the resistor. A filter, it'll be exactly the same. A resistor, you know, that one's a little, that one's a variable because it could be, you know, high resistance, which will affect the diode mode reading, but if it's low resistance, it should be the same. So what I'm going to do is, this is the component here, and if you look closely, you might be able to tell. It looks like a little burnt. Alright, so go back to diode mode. We're going to use the red probe on ground again. So this right side is the same thing as the connector, the pin connector, and still OL. So that means from here to the caps to here is still OL. And on this side, look at that, 445-ish. And it's supposed to be 454. So that's a pretty close, look, it's, the heat also affects the reading, so that's why it's probably increasing as it cools down, returning to normal. So yeah, this is where our reading drops off. So the circuit basically stops here and then it doesn't make it to the other end. That's because of the, actually look at that. We're getting a reading, but it's very, like this is the reading we want. A stable 460 something. Over here it's like jumping all over the place. Yeah, it's not good. See, I'm not even moving my probes and the numbers are going crazy. If I touch this side, it's a solid, you know, 471. This side is very sporadic. So, which should also tell us that this pin, it could be also the pressure I'm putting on the resistor. Anyways, that's our problem there. Obviously, because one side is good, the other side is very weird. So what I'm going to do is replace it. So add some flux. I'm going to see if I could just remove it with my iron. It depends on the resistor itself. Sometimes I can get lucky and just, oh, there it goes. And I picked it up with my iron. So just get that out of there. This tin, those pads. And then, you know what? I've already added a bunch of flux here. Let's clean it up a little bit just so it doesn't build up too bad. Because we do need to clean this. And then especially when the flux gets in the connector, it gets really hard to clean afterwards. So soak it with alcohol and then bring a little towel to clean it. More alcohol and then try to blow it away. If the flux gets too thick like syrup, then it's time to apply a little bit of heat to soften it up again and then clean again. Alright, so there you can see where the resistor used to be. These two pads here. Now, one solution I don't recommend is to run a jumper from here to here. You know, the resistor's there for a reason, so don't just jump it, replace it. Now the question is, where do we get one of these? You can either buy them. I don't know who sells just the resistors, but you can get it from a donor board. So let me grab one. A donor board is basically a dead board or a parts board. And I have a million. Alright, so here's another iPhone 11. As you can see, it's missing a lot of stuff, but really we just want to get under the shield. So in this case, since it's just a parts board, I don't really care about what happens to the board. So I'm going to just use really high temp just to get it off. I don't need to spend time doing anything else. So just get this off. And this is why you need a good board holder, because, you know, I'm prying up. A bad board holder means that this will come loose and then you mess up and you got to keep redoing it. This one holds the board really well, so highly recommend it. I'll link it down below. Alright, so we can just go straight to the exact same components, apply some heat. Alright, let's pull it with my tweezers. Sometimes I could get a little brave and use my iron. Let me see. It's a really tight spot, so I don't think I'll be able to easily place it with my iron. So, let me see if I can get it. And I'll come in from this side. There you go. I don't know if you guys can see that. I have it right there. Now let's swap out the boards. Add some flux. The flux is getting everywhere except the pads I needed to. Alright, there you go. Alright, now this is the tricky part. How do you get this on there? Alright, I'm going to try to heat it from this side and push it into place, which is not working. Kind of. I got one side on there. I'm going to try a little bit of heat. I think I got it. Alright, so let me clean up the area and then test it. Now the heat itself from my iron is not going to damage the resistor, so being that it was stuck on my iron for a while is not going to really do anything. Let's do a visual inspection. It does look a little charred, but that's just from the physical heat of my iron. And let's poke it. Oops. Poke it, doesn't come loose. Alright, now let's go back. We gotta test. Don't just skip the testing. You know, we know what we were seeing before. Now let's see what we see now. Alright. Whatever happens now is gonna determine whether it's fixed. Alright, so let's start at the connector. Second pin, we get 484. Before we're getting OL. On the resistor itself, on the right side, the exact same reading. On the left side, exact same reading. So there you go. This should be fixed. Let's go ahead and test. Alright, so this is a DT80. This is a mini DC power supply, which I do sell on my eBay store, which I'll link down below. I have two versions. One includes the iPhone 11, 12, and 13 cables, as well as iPhone 6 to iPhone XS Max. So I'll link those down below, but this is basically a way to test the board, check the power consumption, you know, as a battery replacement, so you can monitor the current draw. In this case, we don't really care about the current draw. We do want to be able to test the phone to see if it turns on and see if the backlight is fixed. So if we go over here, you're wondering is how do we boot this device? We got to find the power button line. Since we don't have the bottom board connected, we actually have to find it here, which is this pin here, button power key L. Basically what this means is we got to short this to ground to trigger the boot up process. This is a way to, this is basically when you push a power button on a device, it is physically shorting this pin to ground on the bottom board, but the bottom board is not there, so now we got to go to the next point in the circuit. So that coincides with one of these pins here, and essentially what I do is I try to eyeball it and short the pins, and whenever I see the current draw here start moving, that means the device is booting. So I believe this one here, yeah, look at the numbers, shorting to ground, and then oh, I timed it wrong. Let's see, let's try it again. And let go. Depending on model, sometimes you have to hold it longer, sometimes you have to hold it not long enough. and I didn't do it again. One more time. All right, there we go. So it's basically, at least on iPhone 12s, is a lot more pickier than this. But basically, what I did here the last time is, you see it hangs at 115, and then as soon as it starts climbing again, I let go. That seems to work on iPhone 12s, and apparently 11s as well. And there you go, the device booted. iPhone 11 does not require the bottom board for touch, and you can see here, full backlights, no dim spots like we saw in the beginning. So now we gotta reassemble this, test it, and make sure everything else is working. So one of the things I like to do for reinstalling the shields is first, since I added a bunch of solder to the shield, I first apply a lot of flux. I have this on my board heater. This is a board heater I use for iPhone 6 to iPhone 8, although it's a good hot plate to just work on. It's set to 120 Celsius. Now I'm going to actually wick the shield itself, because there's a bunch of excess solder on here. So I'm just gonna try to, usually it bunches up on the edges. Oops, very tricky here. Real gentle with the iron. So what happens is you want to suck up all that solder that's on here so it doesn't bridge and short stuff when you reinstall the shield. The solder that's on the board itself should be sufficient, and you really don't need it perfectly soldered. As long as certain points are soldered on the shields, doesn't move, then you're good. So I'm just kind of randomly applying the, alright, that should be good. It was like real hard to see where that solder was, but then let's go ahead and clean it. Oops. Now it's not going to look pretty at the end, but I mean, it's better than looking pretty and the backlight not working. I don't know if there's really a way. I mean, you could technically replace the sticker on top, but no one looks inside anyway. I suppose you can also just grab a new one from a donor that doesn't look so ugly, but I don't know. What do you guys think? Does it matter? Let me know down below in the comments. Alright, so one thing you'll notice is there's two giant coils here, which corresponds with this. So make sure you align it right. And before I do this, let me warm up this area so I could apply this flux and have it flow nicely. Essentially, flux on the perimeter. And we're gonna just hot air it on just like any other BGA IC chip. Let me start off with 350 Celsius. Although the more difficult part is that it moves a lot. This is very light. Alright, let me try this. Let me try to hold it in place. And the key is really to go in circles. You don't want to overheat just one spot. Alright, that was moving again. Let me get my other tweezers that are really wide. In theory, you don't even need to put the shield back on, but I don't know, up to you guys how you want to handle this. This one's pretty easy to install, all things considered, so I'm just going to go ahead and install it. And I do see the solder melting. I did see some of this part's melting. I was able to push it down, and it does look like it's evenly installed. Essentially, I don't see a bunch of solder here and none here. Same for each side. So it does look centered and installed. Now some alcohol to not just cool it down, but clean off the flux. Remember, there's some flux inside of the shield, so this should help clear out some of that. Although technically this flux is called no clean flux, which means basically it doesn't cause any damage to, if you just leave it. I have seen like excess flux cause really weird issues, so I'd rather just not chance it. All right, so now I'm gonna turn on the board heater. I'm going to clear out some of this thermal paste that kind of got onto the board. Check all the pads, make sure there's nothing dirty. There's no random debris, like dog hairs in my case. This looks a little weird. I'm just going to scrape it off with my tweezers. Oops, out of focus. Alright, top board looks good. Bottom board, let's just inspect. Oftentimes you'll find a random spacer in here that's sticking up. You do want to flatten that out. Now I have had this for maybe a minute now. So let me apply some flux. And I'm not going to reball this sandwich. Being that I was able to clean split the sandwich, I'm actually going to turn it off. Because I do want it warm but not hot where the solder joints are melted. But being that I was able to clean split the sandwich, I'm able to squish it back on, I guess you can say. You can see here, let's see, these solder joints are molten. Okay, they're not molten. Alright, that's good. I don't want them molten. I just want it hot so the flux spreads, but not molten. You want to push them and nothing happens. Because now I gotta put the sandwich lid back on. Now, best way to know which way to do it is see this circle and then this big section. Find the corresponding shape. So this circle goes on the left. And just place it. Alright, now turn the heater back on and quickly align the board. The best way is to just push it. Check the circles here on the posts. Actually, I think I might have aligned it. Alright, there it goes. Essentially up, down, left, and right. So you want to check all those points are good. And just turn it on and wait. So let's come back in about a minute or two and see where this is. You don't touch it. Once you kind of see it's aligned, just let it sit. Be patient. Alright, so now it's been a few minutes, and essentially do the same thing as we did when we were first trying to split it, is push down, and you should see the flux kind of, you can see it here actually. So the flux kind of squishes down. The board still looks aligned. A giant bubble over here. So the thing is, the sandwich solder joints from the factory are low temp. they're 138 or 148, somewhere around there. And what happens is that's basically why I had to split the board to work on it, because since it's low melt, it's really easy to separate the boards and mess it up. I actually have a full video on that, this whole thing right here, where I experiment to see, can I remove the shield without splitting it? And the answer is no. At least not in a practical way. Also, the top board, it tends to warp. So having it in that board holder, it kind of holds the sides from it warping and curving up. So when you have it in that board holder, it grabs the sides, holds it in place as you're applying heat. So even if it wants to warp, it can't. So let's go ahead and cool this down. So now I'm going to turn it off. I'm going to remove these little handles. And what I like to do is kind of just scoop up from underneath and then lift up and then off to the side. And then I grab my tweezers, kind of like a forklift. Now that I have it in midair, I bring my block, my little steel block underneath, and let it cool down. This block acts as a heat sink. The block is cold, the board is hot, and just thermodynamics or whatever causes the heat. The temperature will try to reach equilibrium where they both the same temp. So the cold tries to get hot, the hot tries to get cold, and they basically meet in the middle. And essentially that's the whole concept between a heat sink. It essentially sucks the heat away from the source of the heat, which I'm feeling it now, and it definitely does feel it's still warm but not burning hot. So in a few seconds it should eventually cool down. But I think it's warm enough that I can hold it without burning myself. And you can see the solder joints inside are solid. This is the shield I soldered on. This is all flat, it's not warped. And what I mean by warped is a curved motherboard. Let's flip it over. We're looking at the bottom side now, and we don't see any signs of warping. Everything's soldered on. You can actually see some of the solder joints here are a little bit separated. Let's take a look off the edge of my bench to look at the bottom side. Alright, that kind of looks, it's a large gap, but you can see the solder joints are still making contact top and bottom. So I'm just going to go ahead and roll with it, see what happens. I do know there's a lot of ground on that side as well, so it should be fine. So now let's go back over here to DT880, our mini DC power supply, just to make sure there's no shorts that were created either in the sandwich or installing the shield. And so I'm going to push power. Alright, no current draw before prompt to boot, so that's good. Now that I have the sandwich on there, I can either just use my tweezers, or I have a spare flex here that I can just plug in for this. Alright, that's plugged in. I'm going to push the power button on here and take a look at the DT880. Alright, power button's pressed. Hold it. Alright, it's hanging at 143. And I'm going to let go as soon as it shoots up. Let go. There it goes. Apple logo. Power consumption looks normal. So it looks like it's going to work. And any second now, it'll boot. There you go. So oh, what happened? Turned off. Alright, give me 1 second. I have seen some devices act weird on the DC power supply. That way I don't always test with it. The goal is really just to make sure there's no shorts before prompt to boot. Now I have it in a housing with the battery, and look, it's staying on. So it's just a weird glitch with the DT880. Like I said, DT880 is not meant for long-term testing. It's really just to check the initial boot up, current draw and stuff like that. But yeah, see, it's staying on. Now the key things to this is we want to make sure, since we separated the sandwich, we want to make sure it says no SIM. Wi-Fi and Bluetooth are blue, or at least not grayed out. We could also go here and double check. Wi-Fi, you could turn it on and off. Bluetooth, you could also turn it on and off. So that's working. This should all be working. Another thing you can check, if you want to be sure your sandwich work was good, is open Apple Wallet. If it opens right away, then the NFC circuit is good. If it freezes when you try to open it, or you're trying to unlock it with the pin code and it freezes, that's usually an NFC issue. Now before you go, there is a website called repair.wiki. This is a crowdsourced site where people can post solutions, and Louis Rossmann is looking for people to contribute to the repair wiki, where it is a paying job. Basically, if you can create a full step-by-step process of repairing a specific issue on a device for, like, you know, something popular that comes in often to repair shops, so like Samsungs, iPhones, iPads, MacBooks, something like that, and you can create a guide for this, reach out to me. We're looking for contributors. This is a crowdsourced site, and we want to grow it so that repair shops have a resource to go to be able to solve some of the more complicated issues. So reach out to me if you're interested. Also, I will link down below to all the tools in today's video. I will link to my t-shirt, so if you want to support the channel. I will also link to my locals community, basically a site where I regularly post different repairs I'm working on, you know, the step-by-step of what I did to resolve it and just stuff like that. And it is somewhere you can post as well. So if you post something on there, I do reply regularly for those posts. So appreciate all you guys who stuck around. Check out this video right here where I try to remove a shield on an iPhone 11 and see if I could do it without damaging the sandwich, which is a very interesting video. So check it out. I'll see you guys in the next one. Appreciate you.